Hello, today we are looking at the last section of Chapter 8. Today we are factoring perfect square trinomials. A perfect square trinomial has a sort of formula that it factors into. There are two different cases here, although the only difference between these two cases is the sign that's in the middle term, attached to the middle term in the question and also attached to the middle term in the answer. When you look at a trinomial, you have to first check to see if something is in fact a perfect square trinomial. To check that, you need to make sure that the first term is a perfect square, that the last term is a perfect square, and that the middle term is the product of what you get when you multiply 2 times the square root of the first term times the square root of the last term. And we'll go through that as we look at each question. So first term must be a perfect square, last must be a perfect square, the middle must be 2 times square root of the first times the square root of the last. If you do have a perfect square trinomials factor into the same parenthesis that gets squared. So it factors into a plus b, the whole thing squared, or a minus b, the whole thing squared. When you look inside of the parentheses, it's the square root of the first item plus or minus the square root of the last item. The sign in your answer is dependent upon the middle sign in the question. Those will always be the same. Also make a note that in a perfect square trinomial, the last symbol, last sign, must always be positive. Something cannot be a perfect square if it's a negative number. Let's look at a few examples. So in the first set of questions, it says determine whether each trinomial is a perfect square. If it is, factor it. So when I take a look at question number 1, there are 3 things I need to check. Is the first term a perfect square? Well, x squared is yet in fact a perfect square. Is the last term a perfect square? 81 is a perfect square number. And then the middle term has to be 2 times the square root of the first item. So the square root of x squared is x times the square root of the last item. The square root of 81 is 9. 2 times x times 9 is 18x. But our middle term is 9x. So this is not a perfect square trinomial. It does not fit the correct pattern, so we're not going to factor it. Okay, take a look next at question number 2. Again, first we need to check to make sure that we have a perfect square trinomial. So the first term, a squared, is a perfect square. The last term, 144, is a perfect square number. The middle term must equal 2 times the square root of the first thing. So the square root of a squared is a times the square root of the last thing. The square root of 144 is 12. 2 times a times 12 is 24a. So we do have a perfect square trinomial. In order to factor, we set up one parenthesis that gets squared. Inside of the parenthesis, we put the square root of the first item. So the square root of our first term was a. Then we take the sign from the middle term, so that was a minus, and the square root of the last term, so the square root of 144, which was 12. So this factors into a minus 12 squared. Okay, question number 3. The first term is a perfect square, 4y squared. 121, the last term, is also a perfect square. The middle term has to be 2 times the square root of the first term. So the square root of 4y squared is 2y times the square root of the last term, square root of 121 is 11. If I multiply 2 times 2y times 11, I do get 44y. So this is a perfect square trinomial. So I create one set of parentheses that gets squared. Inside, I put the square root of the first term. That was 2y. The sign from the middle term, which was a minus, and the square root of the last term, 11. So question number 3 factors into 2y minus 11 squared. Question number 4, if we check to see if we have a perfect square trinomial, the first term is not a perfect square. 2 is not a perfect square number. So I automatically can say not a perfect square, so we're not going to factor. In question number 3, if we take a look at our first term, 9n squared is a perfect square. Whoops. But we have a problem. Our terms are not in descending order. So let's start by rewriting this so that our terms are in descending order. So we have 9n squared, but then I'm going to put the plus 42n and then the plus 49. You still need to have descending order. So now our first term is a perfect square. Our last term, 49, is also a perfect square. Check to see that the middle term is 2 times the square root of the first. So the square root of 9n squared is 3n times the square root of the last. Square root of 49 is 7. 2 times 3n times 7 is 42n. So we have a perfect square trinomial. We create one big parenthesis that gets squared. Inside, we put the square root of the first thing. That was 3n. The sign from the middle, which in this case was a plus, but that plus comes from the middle once we have descending order. And then the square root of the last term, which was 7. Question number 6, when we take a look at our first term, 25a squared is a perfect square. Our last term, 144b squared, is a perfect square. To check the middle, we need 2 times the square root of the first term, which is 5a, times the square root of the last term, which is 12b. 2 times 5a times 12b is 120ab. So we have a perfect square trinomial. We make one big parenthesis squared. Inside, we'll put the square root of the first term, 5a, the sign from the middle term, which was a minus, and the square root of the last term, 12b. Okay, when we solve equations that have perfect square trinomials, we're going to start by following the same steps as we've been doing when we've been factoring and solving equations. So far we have learned to move all of our terms to one side in descending order, keep the squared term positive, factor, but then from there things are going to change a little bit. So let's take a look at an example of a solving question with a perfect square trinomial. When you take a look at question number 7, we're going to start by moving all of our terms over to the left. So I'm going to subtract 56c from both sides. When I do that, I'm going to make the minus 56c the second term so that I have descending order. Then I can check my first term is a perfect square, my last term is a perfect square. The middle should be 2 times 7c times 4. That's 2 times square root of the first times square root of the last. 2 times 7c times 4 is 56c. So to factor my perfect square trinomial, I make one big parenthesis that gets squared. Inside I put the square root of the first term, 7c. The sign from our middle term in descending order, so that's a minus. And the square root of the last term, which was 4. Here's where things are a little bit different from what we've solved previously. Once you get to this step, we have one big parenthesis squared, but we need to get rid of that squared. So the opposite of squaring is to square root both sides. When I square root the left side, squaring and square rooting cancel each other out. We just get what's inside of the parentheses, so 7c minus 4. On the right side of the equation, the square root of 0 is just 0. Notice here we only have one equation, so we solve and we end up coming up with just one answer. For perfect square trinomials, that's going to happen. We'll just get one answer. Okay, let's do the same thing for question number 8. So in question number 8, we have all of our terms on one side of the equation equal to 0. The first term is a perfect square. 1/4 is a perfect square because both 1 and 4 are perfect squares. The middle should be 2 times the square root of the first term, which is x, the square root of the last term, which is 1/2. Remember, square the top, square the bottom of the fraction. 2 times x times 1/2 is x. So we have our perfect square trinomial. We make one big parenthesis that gets squared. Inside, we put the square root of the first term, x, the sign from the middle term, minus, and the square root of the last term, 1/2. To solve, to get rid of the squared, we then square root both sides of our equation. Squaring and square rooting cancel each other out, so we just get what's underneath of the radical. On the right side, the square root of 0 is still 0. And when we solve for x, x equals 1/2. Okay, there are two more equations on the back of the notes that I want to go over. Although this doesn't have a perfect square trinomial built into it, actually these two equations have already been factored for you. Notice in questions 9 and 10, you already have your parentheses squared on the left side, but we have a number other than 0 on the right side of our equation. We're going to solve by taking the square root of both sides, just like we did in the last two questions. We want to get rid of that squared. On the left side, when I take the square root of x plus 3 squared, I just get x plus 3. But on the right side of the equation, when I take the square root of 49, remember every number has two square roots, both the positive and the negative version. So the square root of 49 is plus or minus 7. That means we end up needing to create two different equations. One equation that says x plus 3 equals positive 7, and the other equation, x plus 3 equals negative 7. We did not do that in the last two questions because the square root of 0 is just 0. 0 doesn't have a sign. It's neither positive nor negative. However, for every other number, we have to consider both the positive and the negative square root. Now that we've created our two equations, we can solve for x. So when we subtract 3 from the first equation, x equals 4. When we subtract 3 in the second equation, x equals negative 10. And we'll do the same thing for the last question. In question number 10, we have our parentheses squared equals a number. So to get rid of the squared, we square root both sides. On the left side, squaring and square rooting cancel each other out. So we just get y minus 3. On the right side of the equation, we get both positive and negative. The square root of 6 is about 2.4. So you can just type into your calculator square root 6, come up with the decimal. And now we're going to make our two separate equations. So y minus 3 might equal positive 2.4, or y minus 3 might equal negative 2.4. When we add 3 to the first equation, y equals 5.4. And when we add 3 to the second equation, y equals 0.6. Please let me know if you have any questions. The homework is attached just below here, 12 questions.